Okay, so this is problem number 10. Again, let's kind of list what a password would look like. So on problem number 10, so a password that we're going to create is going to look like this. We're going to have 2 letters and then 4 digits. So we'll have a letter, we'll have a second letter, then we'll have 4 digits. Digit 1, digit 2, digit 3, and we're going to just put digits in these boxes, digit 4. Now, how many ways, well, before we even think about the number of ways, let's think about the main 2 questions we typically want to ask on these probability problems. First question is with or without replacement. Okay, so for example, if I pick a letter, can I pick the letter again? Like if I pick the letter B for some reason, can I pick B again? Think about whether that's true or not. If I pick like the digit, 7, could I pick 7 again? Okay, so is replacement allowed? Okay, so if replacement is allowed, then we're just going to multiply the number of ways each choice can be made. Multiply the numbers of choices for each element of your code. Think about, for example, the bike lock problem or the combination lock with 3 different numbers that could be chosen. We did that early on in the homework. Okay, we could choose the first digit 10 ways. We could use the second digit 10 ways. We could choose the third digit 10 ways. So it's just 10 times 10 times 10. Okay, if it's without replacement, then that means that each choice is going to alter the number of choices left over for the next item. And so we have to think about factorials or permutations or combinations. Okay. And then if you decide, so if it's decided it's with replacement, it's just a straight multiplication of your choices. Okay. If it is a without replacement, then permutations like NPR or combinations and CR, what's the difference? Permutations is if the order matters, and combinations is if the order does not matter. Okay, so that's the next choice you would have to make if you decide that we're not replacing. So for example, if I choose like the letter C, could I choose the letter C again? If I choose the number 5, could I choose the number 5 again? That sort of thing. Okay? If so, then you're replacing. C, if you choose C, it's available again to be chosen. It's not used up. If you choose 5, it's available to be chosen again. It's not used up. Okay? If you think it is used up and you cannot choose it again, then you're talking about without replacement, and then you'd be dealing with either the order matters or the order does not matter. Okay? So you should have, so this is your first choice. Your first question is with or without replacement, and then if you decide it's without replacement, then you have a second question to ask yourself about does the order matter or does the order not matter? Okay, so you should be able to handle this based on the material in the previous parts of the video, like the previous part 1 and part 2. All right, so if this is still a little bit difficult for you, just please rewatch the part 1 and part 2 of the video. Okay, all right, so let's go on to the next one. Okay, so here we are on problem number 11, and so we're forming a committee. So let's write out what the committee would look like. We're going to have 2 women and 2 men. Okay, so we'll call the first member woman number 1. We'll call the second member woman number 2. Then we'll have man number 1, and then we'll have man number 2. Now, how do we choose these? Now, since we're choosing women separately from men, that means essentially there's 2 different choice processes. Okay, so for when we're choosing the women, there's 4 women to choose from. Okay, so we're choosing 2 out of a possible 4. Okay, for the men, we're going to choose 2 out of a possible 7. Okay? And so now the question I want to ask myself is, in each of these choice processes, first question is, with or without replacement. So in other words, if I choose, let's say there's a woman named, I don't know, Mary, can I choose Mary twice? If somehow I could choose Mary twice, like I choose Mary and then we somehow put Mary back in and I could choose her a second time and she can be both women, then it's with replacement. I've replaced Mary in the pool of people. Or for men, if I could like choose Bob twice, Bob, okay? That would be with replacement. With replacement would mean just a straight multiplication of options. Okay, without replacement means you're going to have either combinations or permutations. Okay? Now, if you choose without replacement, then your second question is it combinations or permutations? Combinations is what? Order does not matter. Order is not important. Okay, so order does not matter. But if it's permutations, the order does matter. Okay, so which case is it here? When I choose my two women for the committee, does the order matter? If I choose like Mary and then Sally, is that the same as choosing Sally and then Mary? Okay, if that's the same thing, then we're saying order does not matter. If that's a different thing, we're saying if that's the same thing, like Mary, Sally, it's the same as Sally, Mary, then order does not matter. If order does not matter, it's combinations. Okay, if on the other hand, if we're saying choosing, let's say, Sally, Mary is different than Mary than Sally, then we're saying the order does matter, and that would be permutations. Okay, so you have to decide on which one. Once you decide on which one it is, we're just going to use these two numbers in either that. This would be, so we're going to decide on either 4C2 or 4P2. You have to decide which one it is. Okay, and you can get that number from your calculator. That will tell you the number of ways that you can choose the two women. Okay, you don't have to do it separately for each woman in the choice process. The two here is doing it for basically, we're making two choices of people, so we're dealing with both choices, both woman 1 and woman 2, with the same formula. Okay, I'm not going to tell you which one it is, but the 2 is dealing with that for us. Okay, now what about for the men? Same idea. Okay, so it's the same basic selection issue, which is does the order, basically, are we sampling with or without replacement? And then if we're sampling without replacement, meaning you cannot re-choose somebody, then is it order matters or order does not matter? So then basically we'd have to choose between 7P2 versus 7C2. Okay? And you can get both of these on your calculator pretty easily, like I showed you before. And so that will tell you the number of ways these guys can happen. Okay, so basically think of your choice process like this. You basically have a choice process that looks like, so here's your choice number 1. So your choices 1 is for the women, then you have your choices 2 for the men. And both women would be chosen using either 4C2 or 4P2, because this is telling you that 2 are being chosen. Same thing here with the men, 2 are being chosen. So once you compute the correct choice, either 7P2 or 7C2, then you'll get that deals that it essentially does both of the choices for you. It computes the ways that both choices can be made, because that's what the 2 is telling us. And so once we have that, then think of it like essentially like a menu kind of thing. I can choose 2 people off this menu, 2 people off that menu, or 2 people from this group, 2 people from that group. How many people can be how many choices total? Okay, so in this case, that's just a straight multiplication. In other words, there's going to be a certain number of ways to choose the women. There's going to be a certain number of ways to choose the men. And so they're not affecting each other. It's 2 separate choice processes, 2 separate categories. When it's 2 separate categories, then what happens in category 1 is not affecting category 2. So we're not reducing the number each time. So it's just your total number of ways this guy can happen times your total number of ways this guy can happen. Okay, and we just multiply them out. And that's it. Okay? So hopefully you're starting to get a feel for how these things work. All right, let's try number 12. Okay, so we've got 17 students, and we are choosing a first person and a second person. So my choice process is going to look like this. I have to choose student number 1. Say this is student number 1, and then I have to choose student number 2. So first of all, first question to ask yourself is with or without replacement? Again, if it's with replacement, then it's just a straight multiplication of options for each element of the choice. Okay, like think about the bike lock. You can choose, your first digit 10 ways, your second digit 10 ways, your third digit 10 ways. No, you're allowed to repeat because you are replacing the number. It's available again to be chosen again. And so you just multiply. Okay, without replacement, it's more complicated. That's going to be permutations or combinations. Okay, so that's your first question. So can I choose a student and then choose that same student again? If so, then it's with replacement. If not, then it's without replacement. Then your second question is, if it's without replacement, is it permutations or combinations? That's the second question you want to ask yourself. Okay, permutations is order matters. And then we have a permutation formula, right? So NPR is equal to what? N factorial over N minus R factorial. Now, do we divide by another R factorial? Or is that for combinations? Combinations, the order does not matter, right? So that's NCR. Both of them start the same way, N factorial over N minus R factorial. The question is, which one gives us fewer items in the result? If the order matters, then lots of different, like choosing Bob then Mary is different than choosing Mary then Bob. So you get lots of different outcomes, lots of different results. Big number. If I'm saying the order does not matter, then Bob Mary is the same as Mary Bob. They're both the same sort of committee. And so we're reducing the number of options, and so we divide by that extra R factorial factor to group things together. Okay? Right? That's combinations if the order does not matter. Okay? So you have to make a decision what's happening. Okay? And once you do, it should be a pretty straightforward process to figure this out. Okay? All right. And there we go.